A humanoid robot doing martial arts for the price of a used Honda. Your first thought? Dumping, bleeding cash to crush Western rivals. But a leaked teardown report from China Post Securities and Unitree's official IPO filing on my hands reveal a chilling reality. Unitree is not losing a dime. Their gross margin is over 60%. Instead, they are printing money. Let's dissect the Unitree's well-known robot G1 down to the last screw. I'll review the parts bin engineering, the $6,200 leaked receipt of every robot part, and the brutal engineering trade-offs hiding in plain sight. Enough talk, no fluff. Let's dive in. Everyone in the robotics world is asking the same thing. How did the Unitree suddenly drop a fully working humanoid robot? Well, they didn't start from scratch. Digging into their IPO filing, you will find a crazy stat. Before even touching humanoids, they had already sold over 30,000 robot dogs, making them #1 globally. Crack open the G1's joints, which make up 66% of the total hardware cost, and you will recognize them. They use the exact same actuators from their dog models. These parts survived millions of crash tests, meaning the heavy R&D was completely paid off years ago. Now, let's look at its eyes. Buying a 3D LiDAR sensor in the West for spatial mapping usually costs well over $1,000. But look under the G1's visor. You will find an Intel RealSense camera paired with a LiDAR from a company called Livox. Who is Livox? They are incubated by DJI, the massive consumer drone company. Because DJI pumps out millions of drones yearly, their insane manufacturing lines crashed the price of this industrial radar down to just $530. This is the raw power of supply chain spillover. Here's a quick puzzle for you. If this robot uses drone eyes and robot dog muscles, how does it process complex spatial data without a $2,000 automotive AI chip? The answer might be sitting in your living room right now. The G1 doesn't use an expensive self-driving chip like Tesla's FSD. The Teardown reviews a Rockchip RK3588. It's an 8nm processor originally built for smart TV boxes and the security cameras. By borrowing from the high-volume consumer electronics market, they smashed the robot's brain cost down to just $53. With memory added, the whole control board is under $70. Let's recap. By snapping together the paid-off ghost of a robot dog, the vision of John, and the brain of a smart TV, they saved millions in foundational R&D. But physics is a brutal judge. It's time to take a closer look at the Teardown report. Let's strip the Unitree's G1 down to its bare bones. Its retail price is around $13,500. But this Teardown report exposed a shocking number. The total bill of materials, including manufacturing, is about $6,200. It's not government subsidies, it's ruthless engineering. But how is $6,200 built physically possible? Let's look at the most expensive component, the joints. Think of them as a robot's muscle and the ligaments. Even Tesla admits publicly, actuators make up over 56% of Optimus' total cost. Now, look at the G1's teardown data. The planetary reducer for a small joint, $42. The motor, $28. An entire integrated actuator module combining the motor, reducer, encoder, and the drive board costs just $140. So, here comes a big question. How do you slash the price of a robotic joint by over 90% without the robot instantly collapsing under its own weight during a backflip? The answer lies in Unitree's most aggressive strategy. For the robot's 23 muscle systems, they reject 100% of external suppliers. Instead of buying expensive harmonic drives, they engineered their own dual-stage planetary gear systems from scratch. But here's where it gets chilly secretive. When analysts put the G1's custom drive boards under a microscope, they found something highly defensive. The identification numbers and logos on every single critical control chip had been physically scratched off. Zero traceability. Unitree has implemented a highly rigorous anti-reverse engineering framework. Through this deep vertical integration, this company isn't just lowering prices, they are fundamentally re-engineering the cost structure of humanoid robotics. But building chip muscles is only half the battle. You can't slash costs this much without making sacrifices. This takes us to the harsh engineering trade-offs Unitree actually made. We just saw how the G1 is a masterpiece of cost cutting. But the fact is, you don't get a $12,000 robot without brutal trade-offs. Here's exactly what Unitree sacrificed. First, the plastic compromise. Look closely at the teardown. Except a few critical stress points, like the lower leg links which use steel. The G1's body is almost entirely ABS engineering plastic and lightweight aluminum. It weighs just 35 kg, about 77 pounds. Why does this matter? In robotics, weight is the ultimate enemy. Every extra pound means you need stronger, more expensive motors and a massive battery. By keeping it ultralight, they keep the parts incredibly affordable. Before I review the exact number, how much weight do you think a martial arts kicking robot can actually lift with one arm? I'll pause for 3 seconds and take a guess. If you guessed 50 pounds, you are way off. This is the strength compromise. To use those cheaper light motors we talked about, the G1's maximum payload per arm is strictly limited to 2 kilos, about 4.4 pounds. You heard that right? This highly advanced machine literally cannot carry a standard red brick. It's built for agility, not heavy industrial labor. Finally, the stamina compromise. When robot joints do backflips, they generate insane heat. Industrial robots often use complex, expensive liquid cooling. The G1? It's somehow stingy here. It uses a basic fan for the main board. Passive cooling, just like a gaming laptop. If it gets too hot, the software triggers thermal derating to stop the motor magnets from destroying themselves. The real-world cost? Under heavy load, the G1 overheats and forces a shutdown in just 1 to 2 hours. It's not a flawless Terminator. It's a highly specific, calculated trade-off. So, if it can't carry a brick and needs a nap after 2 hours, what is the actual endgame here? Let's take a look at the big picture. Based on all info I have on hand, the G1 was never designed to weld cars or carry heavy payloads. By violently crushing the price down to $13.5 thousand, Unitree is democratizing humanoid hardware. It might be the endured moment for robotics. In this teardown, we have analyzed the eyes and the brain to give the G1 its senses and intelligence. But intelligence is useless without a powerful physical foundation. The real secret to this $13,500 price tag isn't just in the chips. It's in the brawn, the high torque joints, and the high density energy systems that we are seeing under the hood. These hardware components are the direct spoils of war from China's ruthless decade-long electric vehicle bloodbath. And here's a real mystery. Traditional automotive joints took over 50 years to build the industrial molds. How did China manage to compress that entire evolution into just 10 years of hypergrowth? And how did that car war secretly build the foundation for robot mafias? In our next video, I'll be decoding this 10-year industrial sprint. Trust me, it will be something you never heard of. I'm Justin, a China Tech Insider. Hit subscribe, and I will see you next week.